Welcome, guys. So today's lesson is about the circular motion. So let us start our lesson. And for the starter, what are the main objectives of our lesson today? First of all, we need to know what is the centripetal acceleration. Secondly, we will try to discuss the expression of the centripetal acceleration. Also, we will know what is the circular motion and different type of circular motion. For that purpose, I'm going to start with the first thing, that is the difference between rotation and revolution. The rotation is when something or some object turns about an internal axis. So rather to make it difficult, internal axis, we can directly say when something spin around itself, it is called rotation. And when something around moves around some other object, it is called a revolution. For example, I spin football on my finger, it's rotation. I have a mass attached with string and I'm revolving like this, a stone or
Mm.
something, and this is revolution. Whenever we use the word circular motion, an object move in the circular part, always object speed goes on changing. What is the direction of the speed? It's written the word tangential speed. Why we call it tangential speed? Because it's always directed to the tangent. In geometry, if a line touches the circle at one point, this line is called tangent line. If it is touching like the 2 points, it may be diameter or it may be something else, and it will cross the circle, but the tangent doesn't cross the circle. For example, this is a circular path, and this is the object that is moving along the circular path having mass m. This object is moving like this. It is something that is attached to the string. For example, I have a string and I attach something with the string, and it's moving along this. If somehow, by some reason, this string is cut, what will happen? Will this stone, it was moving like this, it
Rhino.
was moving anti-clockwise, will it move to direction A? Will it move to direction B? Will it move to direction C? Will it move to direction D?
It will move to direction D.
Direction D. Why?
So because at the point at where it stopped, it will continue to a straight line. And
Yes.
force
Object
it
is
to
actually while it was moving. Now let me explain the same thing. You are right, absolutely right. If object is at here or at here, this is the center. When object is at this point, direction of the velocity is at this point. When it reach at this point, direction of velocity is at this point. When it reach at this point, velocity is at this point. At this point, direction of the velocity is at this point. So if this rope or string breaks due to any reason, so it will move to its direction of the velocity. It will not keep continue its circular motion, because there is nothing that keep it to move in circular motion. If I was holding the string, then my hand is providing a force to keep it along the circle. When it is broke down and it's cut due to some reason, so there is no force that keep it to the circle. So it will move along the direction of the velocity. Now, if you see the direction of these velocities are like this tangent line, the line that touches. That's why when object move in a circular path, we say that the speed of an object moving along a circular path is tangential, because its direction is always tangent to that point, tangent at any given moment. First of all, we talk about what is the revolution and rotation. Rotation, spinning around itself, moving around some other object, is revolution. Speed of an object that is moving in a circular path is always changing, and it is always directed to the tangent to that point. That's why we call tangential speed. I am hopeful that you guys will understand my drawing. I have a Lamborghini here with me. This is my Lamborghini. You like this one?
Yes, sir.
So this car is moving at 20 meter per second at this point. It is a circular track. So at this point it is here. When it reaches at this point, I will try to explain you your question in my personal way. Now on the circular track, this is the track of the car. When the car reaches at this point, still speed is 20 meter per second. Where it is going? The direction of the speed now this time is here.
Down.
When the car is here, so where is the direction of the
Left.
to the left? And when it is here, it will be to the up. Is the speed changing? I didn't change the speed. I keep the speed same. But every point, every instant, you can see its direction is changing. Where is direction of the car at this point? Even it was on circular motion. It was rotation. It was revolving around this point. During the circular motion, this is a, you can say, any dawar of the on the road, any you can say uh, uh, circular rotation, like you can see in there is an earth globe near the Cornish in Uber, in Basatin. I saw near Slam Mall. What is the mall name? I think so. Is it Slam Mall or somewhere? Where is a globe is there? Dawarpura Ardia. I'm remembering that. You remember that one?
Yes, yes.
This is that circle. The car is moving around that circle, that dawar. So during the motion, at one side its direction is downward, other side its direction to the right, other side direction to the left. So direction is where? If you want to know the direction, make a line tangent to that circle. That tangent is giving you the direction of the speed. So this is called tangential velocity or tangential speed. That's why we use the word that speed is always tangential for the object who is moving in a circular path. If object is moving in a straight line, it's not tangent, it's a straight path. But for the circular path, it is changing its direction at every point. Even the speed is same, we call it tangential. Let me get back to the point. So one thing we know about the speed, when object is moving in a circle, its speed is not changing, but the direction of the speed is changing, and it is always tangent to the point. We said that velocity is the same thing like speed, but there is only difference that speed has no direction and velocity is direction. Now I attach speed and direction both in this topic. So next time I will not use the word speed. If I will say the speed, I will say speed is same. Is velocity same here?
No.
Anybody
No.
please? Why?
Because the direction is changing.
Very good. If any of these things changes, speed changes, we will say velocity is changing. Direction changes, we will say velocity is changing. So even the speed is same in circular motion, direction is changing at every point. In beginning it was on this side, changing at every moment. So we will say velocity is changing. Rate of change in velocity is called, yes please, rate of change in velocity is called
Acceleration.
very good. Whenever object uh, is changing the velocity, we say acceleration is produced, as Umar told us. So acceleration is change in velocity. And also I told you velocity changes in two cases, either if we change the speed or change the direction, or both are changing. But in this scenario, which I tried to show you in the previous page, we see that the object was moving in a circular path but with the same speed, changing direction. So we call that car which was moving in a circular path is having an acceleration. So the acceleration of the object due to change in velocity on the circular track is called, even the speed is constant, is called centripetal acceleration. What is the definition of the centripetal? I am repeating. The acceleration of the object when it is moving in a circular path, it is always directed toward the center of the circle. It is called centripetal acceleration. The word centripetal is really important. Let me write this definition on the next page for your understanding. Whenever I told you the object is moving like this, This is the object, this one. This object is moving in the circular track. Velocity is tangent as we discuss here. This velocity is tangential velocity. This velocity is tangential velocity, and it is moving in a circular path, and this velocity is tangential, and we can say it is changing with respect to time. If the direction of velocity was to the right at this point, when it will reach at this point, it will be to downward direction, it will be to leftward direction, it will be to upward direction. So velocity is changing. We said that acceleration is produced. This acceleration is always directed toward center of the circle around which the object is rotating. So this acceleration is called centripetal acceleration. We use centripetal acceleration like AC, or sometimes we call it AR. AR, why we use AR? AC for centripetal acceleration, AR we use the word for radial acceleration. Why we call it radial acceleration? Because if you see, this is the radius, so this acceleration is along the radius of the circle, so we can also name it radial acceleration. I'm repeating this thing again. If an object is moving in a circle of radius r at some constant speed but changing the direction, has an acceleration whose direction is toward the center of the circle, whose value, the magnitude mean, whose value is equal to a is equal to v square over r. So whenever I will ask you to find centripetal acceleration's value, you can say ar is equal to v square over r, where v is the speed of the object if it is given to you, and r is the radius of the circle around which the object is moving. You will calculate the acceleration. You can use ar or you can use ac. For example, before I go to the question answer, for example, you have this object is moving with 10 meter per second. The velocity of the object, I give you 10 meter, and the circular uh, path within which it is moving is for example 5 meter. I say the circular path is 5 meter and velocity is 10 meter per second. Can anybody answer me what will be the acceleration, centripetal acceleration of this object? It is
2.
v square over r. What is v?
10 meter per second.
It will be
10
20.
square over r is 5. So 10 square becomes 100
100 over 5.
divided by 5. So what will
20.
be your answer?
Equal 20.
Mr.
20
Why?
meter per square second. Yes, given. If the question is find the speed, and they gave us the object acceleration is 20 meter per square second and radius is 5. So to find speed, you will use the same relation. A is equal to v square over r. Just substitute the values. A is 20, v square as it is, r is 5. Now this is v over 1. You will use mathematically cross multiplication. So 5 times 20 is equal to 100 v square. So v is equal to how much? 10 meter per square second. Take the square root on both sides. Okay, this is when you have to find v. If you are going to find r, and keep it in your mind, there are three things: a, v and r. They will provide you two things and one they will ask you. So if they are asking for r, for example, a is again 20 meter per square second and v is, let's say, 10 meter per second. So during the circular motion they ask for r. What you will do? Again you will use same relation. A is equal to v square over r. Just substitute the values. A is 20, v is 10 meter per second square over r. So this is 20 over 1. This is 100 over r. Cross multiply, it is 20r is equal to 100. Divide by 20 on both sides. R is equal to 100 over 20. What it is?
5.
5.
5 meter per second. Sorry, 5 meter. R is equal to 5 meter. One thing I didn't tell you. What is the angle between V and A? You can see from the figure. It's 90 degrees, because yes, A is along the radius, V is tangent. So radius and tangent are always equal to, always having 90-degree angle. First thing, whenever something is revolving, we will say that time to complete one revolution is called its period. For example, if this is the something moving in a circle, it starts the motion from here, This is the center. Start the motion from here to here. Start motion from here and end at here. This is called one revolution. So the time it takes for one revolution is called period. You got it? So period is denoted by T, is time for one revolution. This thing you have to keep it in your mind, what I am writing here. T is called period, is time for one revolution. If I ask you, an object is completing one revolution is 2 seconds. So what is period? 2 seconds. What I said? If this object completes one revolution in 2 seconds, period is 2 seconds. If I say object complete 2 revolutions in 2 seconds, what is period? Very good. Then period is 1 second. How you calculate? To calculate the period, you will use total time divided by
revolutions.
Total time divided by total revolutions. You got it?
Yes.
So whenever I ask you to find period, you will divide time by revolution and answer will be in seconds. Now I am changing my question, making it too difficult. If an object complete 50 revolution in 5 seconds, so what is period?
Half.
You will write 5 seconds above and number of revolution down. 5 over 50 is 0.1 second. It means one revolution takes 0.1 second. 2 revolution 0.2, 10 revolution 1 second, 22 second, 33. Yes, please.
So every 10 revolutions, 1 second.
1 second, very good. So for 50 revolution, it becomes 5. You got this thing? Now I'm getting back to the frequency. Frequency is opposite to the period. Frequency is denoted by F. It is always reciprocal to the period. Frequency is 1 over T and its unit, so we use hertz always because it is 1 over second. Hertz, H-E-R-T-Z, not this one. Not this one. It's hertz. This is H.Z. Hart was the physicist. It is the name of the scientist. Okay. If I ask you to find the frequency for the same object, 50 revolution in 5 seconds. So what you will do? You will do opposite to that. You will write number of revolutions above, time down. So you will write 50 over 5. It will be 10 hertz. You got it? Or you can directly say F is equal to 1 over T, 0.1. So it is 10 hertz. Both ways are correct. But this is the formula for the frequency. Write revolutions as numerator and time as denominator. When object is moving in a circular path with some velocity having radius r, we said that frequency is 1 over t, t is equal to 1 over f. But if someone asks you to find the speed, what we will do? If you remember, the formula of the speed we did study even in grade 7 and 8, that speed is equal to what? Speed is equal to distance over time. Am I right or wrong?
Yes.
Speed is equal to distance traveled per unit time. When speed is equal to distance traveled per unit time, it means object is moving in a circular path. So when it started motion from this point, and after completing one complete round trip, it get back to this point. In a circular path, one complete round trip is called circumference. What we call it? We call it circumference. So distance covered in one revolution is circumference, and time for one revolution is the period. For time period, we use symbol T, and for circumference, we use 2 pi r over T. So whenever someone asks you to find the speed of the object and time period and radius is given, you will use this. And when they ask for you will use A is equal to speed square over R, and speed can be found from here. And if they give you frequency for the same purpose, you will use the same formula. You will use V is equal to 2 pi R over T, or you can say 1 over T. So what is 1 over T? It's F. So you can write it as 2 pi R F. So whenever we are going to find speed, you can use 2 pi R divided by T, or you can use 2 pi R multiplied by F. And to find the acceleration, we will use V square over R. Now, these are all things that we need to compile, and we will use it in our lesson that we are going to take it today. So in our lesson, what we need, first of all, we need to solve a problem related to this thing. For that one, keep these three formulas in your mind, or if you can write them, just write it on a paper. A is equal to 2 pi r over t, a is equal to v square over r, and b is equal to 2 pi r f. Now let me start the problem. For the problem number 1, this is actually example number 1, page number 111, acceleration of a revolving ball. This ball is revolving around the circular orbit having radius r. So what is given to us? We have been given that 150-gram ball at the end of the string is revolving uniformly in a horizontal circle having the radius this. The ball makes these revolutions in 1 second. So there are three things known to us. At 150 gram is the mass. We need to convert gram to kilogram because our SI unit of mass is kilogram.
Yes.
So when you are going to convert gram to kilogram, what you will do? You know that 1 kilogram is equal to 1000 grams. You got
Then
it?
multiply by 0.1.
Okay. Now, if you want gram, so what you will do? Just divide by 1000. So your conversion factor will be 1 kilogram over 1000 is equal to gram. So rather than this gram, what I will write? I will write 150.
0.150.
Yes, I divide it by 1000. So divide 150 by 1000. How much you got? 0.15
kg.
kilogram. The other thing is,
Radius.
okay, I will write radius by r 0.600 meter. I don't need to convert because it's meter. Okay. Frequency is 2 revolutions per second. 2.00 revolution. Now I will repeat one thing. Whenever it's in second, it's time. Whenever revolution per second or hertz, it's frequency. Okay. Now next time, whenever you find the unit revolutions per second, you will say it's frequency. Now we found three things. We have mass, we have radius, we have frequency. What they want from us? Acceleration. So acceleration is denoted by A.
A.
A is equal to V square over R. In this data, we don't have V. V is equal to 2 pi R over T. And there was another. V is equal to 2 pi R F. I can directly use this, or I can find T from F, because F is equal to 1 over T, or T is equal to 1 over F. You remember? So if you want to use this one, convert F into T, divide by 1 over 2. But I don't want this. I will directly use this formula to find V. The first thing I'm going to find is V. For finding the V, I am using 2 pi times R times F. 2 pi times 0.600, F is equal to 2.00. So this is 7.5398 meter per square second. You got it. I am not going to round it off. Why? Because I need this V in the A. So what is A? Now I'm going to find A. To find A, V square over R. What was R?
Mr. 17.
0.6. And what is V?
V is 7.5398.
Okay, I will just write this directly.
7.54.
7.5398. Just take the square of it and divide by 0.6. What I got? 94.748. That's the same. 94.748.
Meter per second
We need to
only.
concern about significant figure. If you see here, mass is 150 gram. It has two significant figures. Mass is, radius, three significant figures. So we need to use the answer for minimum number of significant figure, that is 2. In book this is written 94.75, but I disagree with book, because we
95.
studied in first chapter we will convert the answer
95.
into two significant figure. So your answer for acceleration finally will be 95 meter per square second. Don't forget, when 0 is on the right side, it is not significant. 0 on the right, but after the decimal, it is significant. When 0 is on the left, it's non-significant. Rest of the numbers in between 0 or without 0 numbers are significant. For example, in 150, 0 was on the right side. I said 0 is not included, 1 and 5, 2 significant. Here 0 is on the right, but it is after decimal. So three significant figure, 2.0s after decimal, after non-zero numbers. So these are three significant. So 3, 3 and 2, minimum is 2. I will write my question answer into two significant figure, that is 95 meter per square second. For significant figures, all the numbers 1 to 9 all are significant. All the digits, 1 to 9 significant. 0 in between significant. So how many significant figures here?
3.
109, 3. 190, 0 on the right without decimal,
2.
not significant. Two significant figures. 0.019, 0 on the left side, non-significant. Two significant again. But if 0 is after decimal and after a number like 2.00, so these zeros are even on the right, but after 2 and after decimal, so these are significant. Now these are the basic rules for significant figures. Let me move to exercise A of the same page of the book. In this exercise, it is said that example 5.1, if the radius is doubled, but the period stays same, the centripetal acceleration will change by a factor. When you do radius double, it will become double, 4 times, half, quarter, or none of these. You remember, for acceleration, we have this formula. A is equal to V square over R. Just wait a minute. And also, there is another formula for V is equal to 2 pi R over T. So when we will combine these two, it becomes A is equal to 2 pi R over T squared over R. So A becomes 4 pi square R over T square. 4 is a number, pi is a number, 3.14. This is a constant. Where they said that period is constant. So it means 4 pi and T is constant. So I will write A is equal to constant. All of these three things are constant times R. So this relation says A is proportional to R. This proportional in mathematics is called directly proportional. If R will increase, A will increase simultaneously. If you half the R, A will be half. If you double the R, A will be double. If you triple the R, A will be tripled. I said this
Letter
relation
A.
says that
Mister, but if you
A,
double,
A changes as R changes. This symbol is not equal to. You studied in the algebra and in previous math that there is a relation called direct proportion. Direct proportion mean if one thing increases, the other also increases. If one decreases, other decreases. For example, if you say one student can eat 2 burgers, so 5 students will eat.
10. No. But
I make number of students 5 times, burger becomes 5 times.
yes.
So this is called direct proportion. So A is directly proportional to R means if A is doubled, R is doubled. If R is doubled, A is doubled. It means it will be
A.
doubled. But for this particular question, we can also use another way. Let me show you that way. For this question only, what is that way? If you want to use that way, you can just use the values. Do you remember the values? In the previous question, we use R is equal to 0.6. On doubling it, 2 times 0.6. Got it? It becomes 1.2 meter. Now R is 1.2 meter. You remember in previous question, A was 95
Yes.
meter per square second. Let me check. When we use this R, what will happen to A? So just find the V first. V is equal to 2 pi RF. 2 pi 1.2. F was 2 revolution per second. Okay. When you multiply it, what is your answer? It will become 2 2s are 4. 4 into 1.2. It will be 4.8 pi. Just for simplicity. A is equal to V square over R. So A is equal to 4.8 pi square over R. Can you use your calculator quickly and give me the answer? 189.49.
964.
If you round it off, it becomes 190. It was 95. If we double 95, how much it becomes?
190.
So when you double the radius, acceleration is
Double.
doubled. You got it now?
Yes.
So that was the question. When you double the radius, what will happen to acceleration? It will be
Doubled.
doubled. Okay. This was all about for the example 1 and exercise A.